Okay, today in IM2 we're going to do 4.2, Solving Quadratic Equations by Graphing. This is just giving you an equation. It's graphing it for you. It's showing you that the vertex is -2, -1, and the zeros are -3 and 1. These are the solutions that they're looking for. You have to graph carefully in order to get those good solutions. Every quadratic function has a related quadratic equation. The standard form is this. We've already gone over all this. When writing a quadratic function as it relates to a quadratic equation, you replace y with 0, and we've talked about that before. Okay, so you just replace it. One way to solve a quadratic equation in standard form is to graph the related function and find the x values where y equals 0. In other words, find the zeros of the related function. Recall that a quadratic equation can have 1, 2, or no zeros. So we could have 2 zeros in a graph like this. We could have 1 0 if it just touches once. Those are two different graphs. Or we could have no zeros like that. So solving a quadratic equation, first you write the related function, make sure that it's in standard form, and you write 0. Okay, then you graph the related function. You're going to use your axis of symmetry, your y-intercept, your vertex, and then you find the zeros. So if we were going to graph this one, step 1 would be to write the related function. So they put a 0x there. That's not necessary in my mind, but they did that. Then they found all the pertinent parts. So they've got the axis of symmetry is 0, the vertex is negative 18, and I found two other points, and then they graph them and they reflect them across the x-axis. So what they did was they found certain points and then they found the mirror points. Okay? All right. And then the zeros appear to be 3 and -3. To check them algebraically, there are two ways. You could plug them in to the equation and make sure you get 0. So 2 times 9 minus 18 is 0. Or you could factor the original equation, 2x squared minus 9 equals 0. And that becomes 2x plus 3, x minus 3. And we can see that 3 and -3 are our zeros. Make sure you check them algebraically. That's the most accurate way to do it. Remember, you have lots of tools. Use them all. Okay, so this one they're giving us a fill in the blank option. So of course the first step is to put it into standard form. They want us to find the axis of symmetry, so that'd be -4 over 2 times 2 is -4 over 4 is -1. So we'll put the -1 there. We plug that into the equation and we get the y of our vertex, which is +1. So now we're going to find two other points. If we plug in 0, well, we know that that's our y-intercept, so we'll just put a 3. If we plug in 1, we get 9. So we're going to graph those points, and then we're going to reflect them across and get 5 points total, so we get a nice shape to our graph, and then we can see that there are no zeros. Okay? So that means there are no real number solutions. We're not getting into complex solutions until the end of this chapter. So at this point, it appears to have no zeros. Okay, the root of a polynomial is a value of the variable that makes the polynomial equal to 0. So finding the roots of a quadratic polynomial is the same as solving the related quadratic equation. So now you can see they have all these names for what you're trying to find. Okay? Now, sometimes in word problems, these answers will be the same, but they will not equal the x-intercepts. For example, if you're trying to find when something hit this height, and here's your x-axis, that would not be the x-intercepts. You would be solving for these. That's why the separate answers. Okay, so they graphed this one for us. It's all ready to go. So you can see right away that we have two roots. Our roots are -3 and -1. If we did a diamond and checked this, 3 and 4, it would be 3 and 1, and so that would be x plus 3 and x plus 1, and we can see, yep, those would be my solutions. Okay, find the roots of this one. Okay, first thing I noticed is there's only one. This is a perfect square trinomial, 3x minus 1 squared. Okay, so that means our vertex is at positive 1/3, and that is also our one solution, our one root. Okay, and you can see it graphed that way. So just remember, if you only have one solution, it means it's a perfect square trinomial. Always. Okay? All right, for this one, again, no real roots. Okay, so the most important part of this section is knowing how to understand what is happening with the equation. At what point do things happen, and how do we look at it? So we have a frog jumping straight up from the ground. The quadratic function here models the frog's height above the ground after t seconds. How long is the frog in the air? Well, when the frog leaves the ground, the height is 0, and when it lands, the height is 0. So we're going to solve 0 equals our equation to find the times when the frog leaves and the ground and then lands back down. So write the equation, write the related function, which is the 0, which we learned before, and now we're going to graph the function so to find the zeros. So there's the graph of this function. The frog is off the ground for 3/4 of a second. So he jumps pretty far. Okay? Now, could we have solved this algebraically? Sure. We could have done this. Our zeros are 0 and 3/4. So yeah, that's 75 or 0.75 seconds. So now I want to show you exactly how to understand every part of this graph. Okay, the important thing that you need to do is to be able to analyze the function. What are you learning at each step of your graph? And the graph is really good at showing you this. So first, the frog started at a height of 0. Our y-intercept is 0, and here is the point on the graph. So that tells you where he started, what height. The next step is the highest point that the frog reached was 2 1/4 feet. That's the y of the vertex. If you had found the axis of symmetry, which is right here, and then plugged it in to get the maximum, it would have been 2.25. And then the last thing that we're going to figure out is, well, how long did it take him to reach the highest point, which is your axis of symmetry, and it took 0.375 seconds to reach the highest point. So these are all the things you need to understand about the graph. You also need to understand that whatever the 0 is, this distance is the same. The time you have to be careful is if your graph started at a different height, because here's your axis of symmetry. It's this distance and this distance that are the same. Only when it starts at 0 is it going to be the same from here to here. So be careful of that. And now you get to try this with the exit ticket.